Transformations practice questions. I am eating a Grandma candy right now, so my speech is a little impaired. You'll know why. You're just too delicious for me to pass up. All right, so we're going to work on question 4. All right, so we have this point 24, negative 36, and it's on the graph of f of x. So I can imagine my point, I'll call it point A, lives somewhere on the coordinate plane here at 24, negative 36, and it's on some function f, and f looks like whatever. Doesn't really matter what f looks like. We just know that 24, negative 36 is a point on it. And so when we transform this whole graph, this point goes along for the ride and it gets transformed individually. So we can think of either transforming an entire function or each point individually. And really, the result is going to be the same. So in order to tackle a question like this, we first have to decide what transformations are occurring here. There are 5 in total. I'm going to list them quickly. We've got this negative is a reflection over the x-axis. This negative half means a vertical compression by a half. This 3 means a horizontal compression by a third. The 4 means a shift 4 units to the left. And the 10 means down 10. In this case, because it's negative. Okay. So we decide the order of operations here. So I need to start with my dilations. Doesn't matter which one I start with, so I'm going to start with this one. 1 and 2. And then my reflections, which is, I'll do that third. And fourth, I'll do my translations. Okay, so the point, 24, negative 36, first undergoes a vertical compression by a half. Vertical. It means my y values. So I'm going to compress this value by a half. So instead of 24, negative 36, it's going to be 24 half of negative 36, which is negative 18. Then I'm going to horizontally compress by a factor of a third. So I'm going to take my point 24, I'm going to compress it by a third, which gives me the value 8. 8 is 24 divided by 3. And the y is unchanged. And reflect over the x-axis. So that means that it's going to flip from below the x-axis to above it. That affects the y value because it's vertical in nature, even though we're going over the x-axis, which can be a little confusing, actually. So we multiply the y value by negative 1. That takes us to the point 8, positive 18. And then lastly, I'm going to move 4 units to the left, which means my x value, and 10 units down, which refers to my y value. So it's going to be 8 take away 4 is 4, and 18 take away 10 is 8. And this point is mapped onto my new function. My final answer. I don't know why I decided to write that. I think because I drew an arrow and I didn't know what I was going to put on the other end of it. Okay, moving on to question 5. Pretty similar question, but here it is now abstract. So instead of giving a specific point, we have a general point. We're going to see if we can list all of the transformations and what happens to that point if we know the initial values are just x and y. Okay, so first thing I'm going to do is I'm just going to list all my transformations. But before actually I'm going to do that, sorry, that's not the first thing. The first thing is I'm going to put this into the form y equals a f of b x minus c, not c, h, sorry, plus k. Made a bit of a mess of that. I hope you can make it out. Alright, So as you can see, y is not isolated, so I'm going to add 2 to both sides to isolate y. Y is equal to 3f of negative 4x plus 20 plus 2. And then we're going to recognize that the input into the f function is not in this form where the coefficient on x has been factored out. So I'm going to factor this negative 4 out of the expression, leaving me with an x minus 5. Okay. Now I can see the transformations that are occurring. So the first transformation is I have a vertical expansion by 3. I have a negative, which means a reflection over the y-axis, over the y-axis. This 4 means a horizontal compression by a quarter. I'm going to shift 5 units right. I'm going to shift down 2 units. And so I'm going to start with my dilations. Then I'm going to do my reflection. And then I'm going to do my translations. Okay. So the point x, y, after we're expanded vertically by 3, is replaced by the point, well, x isn't changed, but now instead of y, we have 3y. Now, we're going to move on again. We're going to manipulate it so that we horizontally compress by a quarter. That's going to affect the x value and replace it with a quarter of the x value. The third step is a reflection over the it's a reflection over the y-axis. And that has the effect of changing the x value from being on the right side to the left side of the axis. And so instead we multiply this by negative 1, take the negative version of my original x coordinate. And then lastly we're going to add 5 to x. And we're going to take away 2 from y. Negative x over 4 plus 5 and 3y. Take away 2. And that's our final answer. Okay. So the next question asks us to rewrite f of x such that these transformations have been written into it. All right, that's not so bad. Just trying to decide what to do with this paper, actually. All right. So I'm going to try to frame it such that both transformations or all the transformations are visible. All right. We start with a vertical stretch by a factor of 4. That means my a value is 4. My b value is a stretch by a factor of 3, so that means I'm going to have a b value of a third. Oh, but I have a reflection over the y-axis. That's going to affect my b value, make it negative. Now we've got translation 5 units right. So that means my h value is 5. My k value moves 6 units up, so that's 6. So all I need to do now is write out my general function, y equals 4 f of negative a third x take away 5 plus 6. And we're done. Pretty painless, actually. We're going to repeat this with question 7, except for a specific function, not a general function. All right, vertical stretch by a factor of 4. A is 4. Vertical stretch by a factor of... Wait a second. I screwed all this up. I was reading these transformations for this question. Can I salvage this work? I don't think it's wise. Let's try that again. For 6, I have a vertical stretch by a factor of 2, meaning A is 2. Horizontal stretch by a factor of 3/2, which means I actually have B value of the reciprocal of 3/2. Reflection over the x-axis means my A value takes a negative component. My H value, shifting 3 units down, that's actually a K value. It tells me I'm going to go down 3 units, so it's -3. 3 units to the left, that means my H value is -2. So to write that, I'm just going to replace A with -2. F of B value of 2/3. H x take away -2, which is when you take away -2, you're really adding 2. We're going to take 3 away from the outside. And that is our correct answer for 6. Moving on to question 7. I think I can answer this right on here. That's my vertical stretch by a factor of 4. That tells me an A value is 4. Horizontal stretch by a factor of 3. That means my B value is 1/3. Reflection of the y-axis actually means I have a -1/3 for B. And my translation 5 units right, that means H is 5 and 6 units up, meaning K is 6. So, this tells me that my new function is going to have a multiplier in front of 4. And I'm still going to have this regular thing on the inside of the square root, but I'm going to replace my input. Set of x is going to be -1/3 x with a bracket. Maybe I can write this a little bigger. I'm realizing it doesn't show up that big on the screen. So y is equal to 4 square root 1 take away. And instead of x, I'm going to be squaring my input. And my input is going to be a b value. And I'm going to take away 5. And close that bracket. And I'm going to add 6 on the outside. Okay. So I don't want to isolate or simplify that, so I'm going to leave it the way it is. Can I do that? Can I just leave it? Well, I'm looking back at the question. It doesn't ask me to simplify. So I'm going to leave it as such, which is poor form. It actually irks me a little bit. I really want to simplify that. It really is because I didn't make any room for myself that I'm choosing not to. All right. I really have a hard time leaving that. Me just leaving something unsimplified just leaves me with a deep sense of dissatisfaction. So I think maybe over on this paper I'm going to do a little simplification. So first I'm going to multiply that -1/3 in. So really this is going to be -1 minus, it's just going to be -x/3 plus 5/3. Oh, this is going to be gross. So then I'm going to square it. I'm going to square that to the side. So -x cubed, or -x/3 plus 5/3 times -x/3 plus 5/3. I don't know why I'm doing this. This is stupid. Then I'll multiply across, so I get x²/9 plus multiply these guys, so it gives us actually, a -5x/9. And then these guys also give us another -5x/9, and then plus 15/9. And that's all back into the equation. So I got y is equal to 4 square root of 1. Take away all this. Let's take away x squared minus 9. And that'll change these to, take away these negative values, run through additions. Plus, and I'm going to group the like terms while I'm at it. So plus 10x over 9. And we're taking away 15 over 9 as well, because we took away this whole set of brackets. And then we add 6, and then I still have some like terms. So I'm going to say, okay, well, 1 is the same thing as 9 over 9. I'm going to take away 15 over 9, so say the same thing, as negative 6 over 9, which is negative 2/3. All right, so then really what I have is y is 4 minus x squared over 9 plus 10x over 9 minus 2/3. Now, plus 6. Like, you can keep going. Like, the question of what is the most simplified form, I could actually see that I can take a 9 and square root it out of this set of brackets to make this 4/3 times the square root of all this, which I am going to do. I'm going to replace that with a 6/9 again. I'm going to factor a 9 out the front, so it's going to be y is 4 1/9 negative x squared plus, plus 10x, take away 6, plus 6. And I'm going to square root that value. So it's going to be y is equal to 4 times 1/3 root negative x squared plus 10x minus 6 plus 6. And I should probably make that into a single fraction. So it's 4/3 negative x squared plus 10x, take away 6. Okay. And then I have a simplified answer that I'm happy with. I can't see any other way to simplify that, and so I would say that's done. Now, you may say that was an obsessive move, going from this statement to this statement. However, as somebody who has already been through calculus, I can tell you that being able to do this that's a habit you're going to find yourself getting into. Because it just turns out that when you can make this into a simpler expression, you can do more straightforward operations to a function involving calculus. So, I mean, especially if you end up going to first year calculus, like, don't be surprised if you find yourself doing this, and maybe on the other end of that whole process, finding just as much of a OCD response to an unsimplified expression. All right. Now, looking back and reflecting, I realize I probably could have taken that third out earlier and made my life a little simpler. And that's just the way she goes sometimes. All right, let's move on. I'm going to label that as 7 simplified. And I would say that is probably more a note for the people planning to go into calculus, particularly planning to go into pursue sciences in university and taking calculus first year. Just know you'll be seeing stuff like that. And if you don't want to do stuff like that, I would suggest, I almost said you shouldn't go into the root of calculus, but what I should actually say is you should learn to be okay with this, because calculus is really worth learning. I would highly recommend taking some extra time to feel comfortable with going through steps like these, so that when you get to calculus, you can just focus on the really amazing ideas. All right, let's move on. All right, question 8 asks us to describe transformations based on the equation and draw a sketch. And we'll highlight them in different colors. Okay, great. So this negative in front, that reflects over the x-axis. So that's a reflection over x, or the x-axis. And I'm going to use black for that. So I'm going to indicate that that's A. And then I'm going to use red to say this is a reflection over the y-axis. So that means we're going to go through here and up to there. And it's not a perfect curve, but I'm not going to obsess over it, and that's B. And then lastly, I don't have a really good third color. Oh, use a Sharpie. Nope, that's a dumb idea. All right, so this is a reflection over both. That's not going to scan well. I've got a red. Hey, look at me. Reflection over both axes. So that means a reflection over here and then a reflection downward. Or you can think of it as a reflection downward, then a reflection across it. It will give us the same shape. Just drawing my points so I can connect a little bit more nicely this time. And that's C. All right, let me know if you have any questions about any of those. And that diversion in question 7, I'd say you can safely ignore. After going through the process, I realize I'm probably not going to ask any of my students to go through that unless they are really planning on pursuing a particular path in their lives. All right.